Greetings to every one of you. So in this video we are going to discuss another very important concept from data structures and algorithms, that is insertion sort. So in this algorithm, the given array, it is divided into two parts. So one is sorted and another is unsorted. So keeping that sorted array on our left hand side and unsorted array on the right hand side. Take the element from this unsorted array, insert that element in the sorted array in the corresponding or appropriate place. So this is what actually we are going to do in this algorithm. See, for example, this is a given array contains set of elements. So consider we are keeping this first element as a sorted one and remaining elements are unsorted. Okay, so now we have to, that is, take the element from the unsorted array that we have to, that is, insert in the appropriate position in the sorted array. So before seeing this example, now let us see this algorithm. So the algorithm of insertion sort can be written as for I is equal to, that is 1 to n. Here you are storing this value, that is a of I, in a variable, that is temp, and another index variable we need, that is j, and that value it is initialized as j is equal to I minus 1. We need to do another loop while j is greater than or equal to 0 and this a of j, it is greater than temp. That being the case, we have to do the operation, that is a of j plus 1, it is replaced by a of j, and this j value, it is decremented by 1, and finally this a of j plus 1, in which will store this temporary value. So we have two loops, the inner loop, this is the inner loop and this is the outer loop. Now let us see this example. So in this example we have totally 6 elements are there, and the first element, we keep the first element on left hand side, the remaining elements on the right hand side. So initially we are taking the the first element, that is on the sorted unsorted array, and store it in the variable, that is the temp. So here the temporary variable, that is temp, is equal to 40. So that is what actually we have done here. Okay, so we are taking the value, that is I is equal to 1. So we are storing this a of 1 in the variable, that is temp. So now we have to compare this value with the previous value, that is the first element in the sorted array. So this portion is sorted and this is unsorted. So 50, it is greater than 40. So we are checking the condition. So we have to check two conditions, that is what if the j value is greater than or equal to 0 and this a of j, it is greater than temp. So both the condition, we see that here the value of I is equal to, that is 1, and j is equal to 0. J is 0, j is initialized as I minus 1, so that is 0. So now this the value contained in the variable, that is temp, that is compared. So 50 is greater than 40, yes, condition is true. So what we have to do, we have to change this, that is in a of j plus 1, we have to store this value, that is a of j. So a of j plus 1, it is nothing but location 1. So the 50 will be stored in the location 1. Okay, now actually this position is we don't know the value, and again we have to, that is, check the condition. We see that the value of j, it is decremented by 1. So originally the value is what's that, 0, and now it has become what's that, minus 1. So here we do the operation, that is a of j plus 1. So minus 1 plus 1, it is 0. So that is the temporary value will be stored in a of 0. So it is nothing but what's the temporary value, that is 40. 40 will be stored in the location a of 0. So two elements are sorted now. Up to this point it is sorted. So the remaining values are as it is 90, 6, 60, 20. Now the I value is 2 and j value is 1. Again we are checking the condition, j is greater than or equal to 0 and a of j greater than temp. So what is the temporary value now? So we have to store this value, that is temporary value is nothing but 90. Now we have to compare this value with this elements in the sorted array. So take this value, that is 90, compare it here, 50 greater than 90, the condition is false. This condition is false. So what will happen? This loop will not be executed. So automatically it will come to here. So a of j plus 1 is equal to 10. So what is a of j value is equal to 1. So j plus 1 is nothing but 2. So in the location 2 we have to store this value, that is 90. So it is nothing but as it is. So the remaining values will be that is stored as it is. Okay. So up to this point we have performed, we have sorted. So 3 elements are sorted and 3 elements yet to start. So now I value is 3. Okay. So now temporary variable is equal to, in the temporary value it is nothing but 6 is stored. Okay. These values are same. Now 6 is stored in the temporary variable. Now we have to compare this value. So 6 is compared with 90. 90 is greater than 6. So we have to shift this value. Okay. So this location actually we don't know. So the remaining values are same. Now again take the value, that is 6. That should be, that is compared with the next value, that is 50. 50 greater than 6. Yes, condition is true. So automatically what will happen? This 50 will be stored into this position, next position. Okay. Now take the value, that is 6, compare it with 40. Yes, 40 is greater than 6. Yes, stored here. 40 is stored here. So this location we don't know the value. So now what we have to do? We compare this. So no more element to compare. So automatically we can store this 6 here. Say 6, 40 and 50, 90, 60 and 20. Okay. So now take I value is 4. The next iteration I takes value, that is 4 and j value is 3. Okay. What is the temporary value? So up to this point we have up to this point it is sorted. Up to this is sorted. So 2 elements yet to start. Okay. So temporary variable contain the value, that is 60. Okay. Compare this value 60 with the 90. Okay. So 90 is greater than 60. So we have to shift the value, that is 90. We don't know the value for this position and the remaining values are same. So now again you compare this 60 with 50. Okay. So 50 is greater than 60. No, condition is false. So automatically what will happen? The 60 will be, that is stored in the same position. 6, this is 90 and this is 20. So up to this point it is sorted. Okay. So we have only one element here to start. Okay. So now store this value, that is a temporary variable, that is 20. Now take the 20, compare it with 90. Okay. 90 is greater than 20. Yes. So automatically what will happen? 90 will be stored here. So this position we don't know. So this is 50, 40 and this is 6. Now take 20 and compare it with the next element, that is 60. So here also 60 is greater than 20. Yes. So automatically what will happen? 60 will be shifted to this position. Okay. So this position we don't know the value. So the remaining values are stored as it is. Now take that is 50, compare it with 50. So 50 greater than 20. Yes, condition is true. So automatically 50 will be shifted to the next location. Right shift. Okay. So this is 60, this is 90. This location we don't know. This is 40 and this is 6. Now take the value, that is 20, compare it with 40. Okay, so 40 is greater than 20. Yes, condition is true. So automatically 40 will be shifted here, and this is 50, and this is 60, this is 90. Okay, this position we don't know, this is 6. Take 20, again compare it with the next value. What is that? 6. 6 greater than 20. The condition is false. Okay, the condition is false. So automatically, so what will happen? 20 will be, that is stored in its position as it is. Okay. So up to this fifth iteration, we are able to, that is perform this and find that the array, the given array is get sorted. So listen carefully. Here we have two loops. So this is the inner loop and this is the outer loop. So the outer loop, it is for the overall iteration, that is I takes value here, and we have the inner loop in order to, that is move the the pointer from right to left. For that we are using the variable, that is j. So j will move in this direction and I will move in this direction. Okay, so that you have to understand. So as far time complexity is concerned in this algorithm, so we have we are performing this loop for a number of times, and similarly here we are performing that loop for n minus 1 number of times. So every time, so in the worst case, if you consider, it is nothing but the time complexity, it is order of n square. Suppose let us consider if it is the best case, if the given number is total number, it is in the ascending order. Let us consider this is the given array. So that being the case, you will get the time complexity as order of n. This is for the best case. For the worst case, the time complexity for insertion sort, it is n square. So wherever we have two, that is loops, so automatically we will have this only this n square. We will get the worst case, that is n square. Okay, so the formula maybe that is it comes like this: n into n minus 1 by 2. So what will happen? It is n square minus n by 2. So it is nothing but order of n square. Okay, so I hope you understood the concept. I explained the details about insertion sorts, and I gave the algorithm and I explained with example, and also I discussed about the time complexity. So for the worst case it is n square, the best case it is n. Okay, so without executing this inner loop, you will get this order of n. If you execute both the loops, you will get n square. Thank you.